Welcome to another exciting segment of Math with Miss Bennett. Today we're going to talk about box plots. Box plots are a way to display data that focuses primarily on the median and the spread. In order to create a box plot, you will need to be able to calculate a 5-number summary. The 5-number summary is a lot more simple than it sounds. You need to find the minimum and maximum of the data, the median, and the lower and upper quartile. And these are sort of like medians of halves. And you'll see how that works in just a moment. Let's say you were given the following set of data. You'd need to calculate your 5-number summary. So let's start with our 5-number summary. The minimum is the smallest number in the data set. So that's 14. Conveniently, my data set is already in order. The maximum is the largest number in the data set. That's 30. Now we need to find the median. Typically, we mark values off when we're finding the median. However, we're going to want to be able to see these values, so I'm actually not going to mark them off. I'm just going to count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I have 20 data values, so my median is going to be between the middle 10. Excuse me, the 10th and 11th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the median is perfectly in between 22 and 24. Now, some of us would automatically know that perfectly in between 22 and 24 is 23. If it wasn't so easy, you could simply add the two numbers. 22 plus 24 is 46. And then divide by 2 to get 23. Next, we're going to find the upper and lower quartiles. And if you see that word quartile, I want you to look at that quart in it, because it literally is a quarter. It's half of the lower half or half of the upper half. So let's start with the lower quartile. Never include the median. The reason we never include the median is sometimes our median is another data value, like this 23. It's not actually in the set. So we don't want to include the median in case if it's not even there when we're counting off our values. So now I'm going to find the median of each set. 1, 1, 2, 2, 3, 3, 4, 4. My median is in between 16 and 17, which is 16.5. So my lower median, my lower quartile is 16.5. And then for my upper quartile, low, high, low, high, low, high, low, high. What's perfectly in between 28 and 29? That's 28.5. So my upper median, or my upper quartile, median of the upper half, is 28.5. With these 5 values, I can create a box plot. In order to create a box plot, you're going to need a number line, just like you would for a dot plot. You'll need to include the minimum and the maximum within that number line. You can always go a little lower or a little higher, but you don't have to. I start with my minimum and maximum and draw a dot above the number line, not on it. Then I move on to my median. For my median, I'm going to draw a little vertical line. So I'm going to find 23 and draw a little vertical line. Then I'm going to find my lower quartile, which is 16.5. So 16.5 is perfectly in between 17 and 16. And draw myself that little vertical line. And then for my upper quartile, I'm going to find 28.5. Draw myself that little vertical line. And then I'm going to connect everything. The vertical lines all connect to make a box. And then the minimum and maximum connect to make what some people call the whiskers. This is sometimes referred to as a box and whisker plot. And there you have it. You've created a box plot. The reason I erased the data was not just to make things fit. A lot of times with a box plot, you're not given the data. So you've got to be able to interpret what you've got. Let's relabel this. Minimum, maximum, median, we'll call the LQ, and the upper quartile the UQ. Dot plots show us all the data. Box plots just show us the spread and the median. They're about measuring those two things very specifically. So taking a look at this box plot, we can see a couple of things. First of all, we can tell that the quartiles each represent 25% of the data. And there are 4 quartiles because each part is 25%. So that's the 2 halves of the box and the 2 whiskers. Looking at our data, we can tell that half of our data, or 50%, is below 23. We can also tell that 50% is above 23. And statistically speaking, finding the center of data is very useful. We can also see that the middle 50% or the IQR, which we call the interquartile range, is pretty large. It's very spread out, going from 28.5 to 16.5. We have an IQR, or interquartile range, between the quartiles range of 12. That's a pretty big range for the middle half of the data. This is some very inconsistent data. If we look at the 2 whiskers, which I'm going to mark here real quick, here and here, we can tell that the upper and lower 25% of the data has a lot less variety or spread than the middle 50% of the data. So at the upper and lower extremes, the data is very consistent. It's very tightly packed. There might be a lot of repeated numbers or close numbers, but when you get to the middle 50% of the data, there's a lot of variety. It's just a few things we can tell about a box plot. Box plots tend to make people uncomfortable because they can't see the actual data. The point of a box plot is not to see the data. It's just to tell the spread and the median. So if you were using a box plot to find a typical value, your typical center value couldn't be the mean, not unless they gave you the data values. You would have to choose the median. So if you wanted to know the typical value, you would have to choose that 23 because that's the median. You can't find the mean unless they tell you the values. So looking back over these things, a box plot is a way to display data that focuses primarily on the median and the spread. You have to know the minimum, maximum, median, and lower and upper quartiles to find a box plot or create a box plot. Box plots do not show data. They do not show the exact data values, which makes a lot of people very uncomfortable with them. What they do instead is they focus on the spread or the variation and the median, which is the center. This makes them really great for large amounts of data where nobody would want to draw that many dots for a dot plot. Again, this has been an exciting segment of Math with Miss Bennett. I hope this helps you understand box plots.